Alright, welcome back, Intro to Engineering. This is going to be on Activity 5.5a. So if you go to your My PL2W, that would be Cad Models Features Part 1. I'm going to tell you right now, we are only going to do Part 1, so use the revolve function to create the rubber handle sleeve for a button maker. We're going to skip all of 2, so you're going to create the rubber handle and that's it, okay? You're going to skip part 2, you're going to go down to part 3, create a model of the circular plate with holes as shown as above, okay? You're going to continue on and do part 4, okay, and you're going to create this flanged plate part, and that's it. You're not going to go any further than that. So 1, 3, and 4 for this assignment. So let's go over this to start, and I will go it along with you. So let's start with the rubber handle sleeve. Okay, to start, we're going to create a rectangle. I'm going to start a sketch on the XY plane, and we're going to create a rectangle like so. And that's using the rectangle tool, clicking to start it, click where you want to end it. Don't worry too much about dimensions at this point because we're going to go back and dimension it anyways. So we know it's going to be 4.469 inches long. Okay. And we know that we're going to have some different diameters. So we're going to revolve the object to start. I'm going to actually delete one of these lines. Okay. It's 4.469. The thickness is going to be 0.156. The reason I'm doing it like this is because we're going to end up getting rid of some of this, and then when we do the revolve, it'll be a little bit different. So we have the thickness as 0.156 over here. Okay. The thickness of this part is 0.25. Uh, 4.469 long. Okay. I think that's all we need for right now. To create that hole, okay, what we're going to do is, if you see this here, that hole right there is a diameter of 0.1875. Okay, we're going to add that space in there for a construction line so that it automatically gets created when we do this revolve function. So to do a construction line up here, you'll see construction. I can click on that, and now I can actually draw a construction line. And what that means is it's a dotted line. It's not used for an actual object, but we can dimension from it. So if the diameter of this hole is supposed to be 0.1875, then that means from the center would be half of that. So I'm going to do 0.1875 and then slash 2. So 0.1875 divided by 2. And it brings that in. Okay. That's there. Okay. I think that will do that. Alright, so let's give this a shot. So we'll finish the sketch. I'm going to zoom out. And then to do a revolve, you select on the object you want to revolve. And it automatically selected what we're going to revolve. And then we select the axis we want to revolve around. And that would be there. Okay. Now, I don't think that was right because that looks completely wrong. So let's go back. There's something we forgot to do in our sketch. So to get back to our sketch, over in the browser window, okay, we're going to double click on sketch, and now we're in the sketch again. And click on the front. We don't have the correct dimension from here to the outside. And to know what that is, right, we have to go back to our drawing, and it gives it to us. The outer diameter, OD, is a diameter of 1.375. Not bad. Okay. So let's go ahead and put that in. Okay. 1.375. That means the dimension from here to the outside is not 1.375, but it's half of that. So 1.375 divided by 2. Okay. Aha. That looks much better. So we're going to zoom out again, revolve. There's our axis. Okay. That looks much closer to what we're supposed to be having. Next, the outside, the edge here needs to be fillet. It needs a fillet command. So we're going to click on this, and we're going to tell it what it needs to be, and according to our drawing over here, that is a fillet of 0.25. Okay. And the same on the opposite side should be correct. That's around. Yeah. So then this side should also be a fillet of 0.25. Boom. And now we have this object as shown. Okay, there you go. So that would be that object. So now let's go ahead and move on to the third object. Make sure you save your files in the right order. So we'll up to File, Save As. You'll have an H drive. I'm going to save on my hard drive. Maybe. There we go. And then I will save it as the button maker handle. Alright, so that's that object. Now we'll do a second object, and that would be for holes. Okay, and I'm going to use this right off of 5.5a to create that. So to start, I'm going to exit out of this. I'm going to do a new sketch, new part, new sketch, and then I'm going to start with some circles here. And that outer diameter is supposed to be 4 inches. Okay. And then I'm going to do a construction line for this next circle because I'm going to use that as a basis. That's 2.5. Alright. So now I'm going to extrude this here. I'm going to go the opposite direction though. Boom. And what happened when I did that is my other sketch disappeared. So I can actually open my extrusion over here in the browser, right click on sketch, and turn on the visibility. Okay, so now I'm there, and I can do a new sketch on this surface here. And from there, I'm going to do some different points, okay? I'm going to use a point, and you're going to end up doing several sketches to do this, but I'm going to drop a point there, drop a point somewhere over here, over here, over here, and over there. Alright, this was a terrible way to do it, okay? So what we're going to do is I'm going to do Control Z, and that's going to go back. Okay, so what I need is, I need a point to be there. And to make sure that point's where I need it to be, okay, I'm going to make sure that it is half of the diameter of 2.5. So 2.5 divided by 2. Now it's definitely on that line right there. And that's exactly where I need it. Alright, and to make sure those are actually vertical to each other, I'm going to constrain this point to that point. And that's called a vertical constraint. So when I click on that, I said I need this point to be vertical to that, and that just ensured it. It was probably already there, but now it for sure is. Next, I'm going to use a command that allows us to create multiple points. So there are 5 points, and they are 72 degrees apart from each other. So how we do that is we are going to do what's called a circular pattern. So up here I have circular, and I'm going to select the geometry that I want to copy. That would be the point itself. I want the axis that it's going to go around. Should be there. Okay, that's not going to work. So you don't have to do a point, we can do a circle. So now we'll do a circle instead. Okay, points aren't going to work for some reason. Dimension of the circle doesn't matter, you're just going to use it for a hole later on. So the geometry we want to copy is this. The axis we want to rotate around is that. Why is it not working? Geometry and alright. It's being difficult. Let's try this. Okay, so there's the geometry, and the axis would be there. And I want 5 of those. Okay. So those are my 5. And theoretically, if I go from there to there, yeah, let's do the other way. There to there to there. That should be 72, and it is. Okay. I'll accept that. So what I did is, let's go back here. Okay. What happened is, this is from an old sketch, and so it wasn't allowing us to select it. So after I drew this circle, I drew another circle based off this point, and I made sure that was also 2.5. And now that was there, I can do circular. So first I select the geometry I want to, Next I select the axis I want to rotate around, and you'll see this arrow pop up. And then I specify how many circles I want. And then, so there's 5 at 72 degrees. Don't worry about changing this. It'll fit it in. and that would be 5 at 72 degrees. So then I could finish this sketch. Okay. And then the next part is to actually do the holes themselves. And 1 second, I just got logged out. So let's do this first hole. This first hole, we're going to just click hole command, okay? And you select the point. You should be able to select a point. And that is supposed to be over here. So these diameters, the diameters of these circles don't matter. You're using the point of the circle to determine. So the first one is 0.25 diameter through. So you see 0.25, and then termination would be through all. So I'm going to do OK, and it's all there. And it's, oh no, all of my circles went away. Not to worry, let's go back into hole 1. Open up this. Once you open that, right click on sketch 2 and turn the visibility on again. Now we can go at it again. So click on hole, and then we're going to click on, you gotta be kidding me. So you don't have to click on hole, go just find it, click on the dot inside the hole, and you'll get this little bar here. I'm going to create a hole. Now this one is supposed to be a diameter of 0.375 through, and it's got a counter bore. Counter bore, you'll see which one's which by just putting your mouse over it. So that'd be your counter bore. This is a spot face, this is a countersink, and this is a drilled hole. So we got counter bore. The counter bore is 0.375. It then has the hole itself is 0.75, and the counter bore goes 0.25 down. Sorry. The counter bore is a diameter of 0.375. I'm having trouble reading this for a second. 0.375 through. The depth would be 0.25. The counter bore is 0.75. Nope. Yeah, the diameter of that's 0.75. And the hole goes down 0.25. And then through. So, reading through this here, okay. The hole, here. Okay. So first off, the diameter of it is 0.375. So, my goodness. So up here we have a diameter of 0.375, and here it shows that the hole itself is a 0.75 diameter. So here we have 0.75, and then it is 0.25 down. Okay, that 0.25 with the little arrow, is referring to the counter bore itself. The counter bore is 0.75 in diameter. Oh, I just realized I flip-flopped. So the counter bore is 0.75, and it is 25 down. The hole itself is 0.375. So I have these two flip-flopped. Okay, and then it is 0.25 down. And then the hole itself is 0.375 through. Okay, so that through means it goes all the way through. So here is the hole commands. So diameter, the hole itself is 0.375 all the way through. And then this shape here stands for counter bore. The counter bore has a diameter of 0.75 and goes down a 1/4 inch. All right, so that's that hole. So we'll go ahead, okay. And now we'll move on to the next one. So I'm going to scroll down, click, hole, and this one is going to be a countersink, and the hole itself is 0.375. I already have it right there. The countersink is 0.75 diameter and 82 degrees. Okay, and it also says all the way through, so they'll be through all. Okay, so we're doing good so far. The next hole then is it says a 1/4-20 UNC, 1B down 0.75. Okay, so those are some different things here. That means it's going to be a drilled hole. Okay. The drilled hole is going to have threads. It's going to be tapped. All right. Okay, there we go. So it's going to be a tapped hole. And you got different types here. So all these ANSI, unified screw threads, blah, blah. All right, we're going to keep it right there, unified screw threads. The size is 1/4-20 UNC. So designation, we're looking for 1/4-20 UNC. You're not going to see that because our size is not correct. So we need to change that to 0.25. 0.25. Now we have 1/4-20 UNC. Class is going to be, it says 1B, so we need to change that to 1B. And it is only going down 0.75. So instead of through all, there's going to be a distance. That 1B is going to go down 0.75. And that's the total hole. And then the threads themselves are going to be 0.75 as well. We're going to apply that. Okay, so that hole is threaded. You can see it now, right? Oop. And the last hole, we'll click here, hole, and it is going to be what is that? I don't see any measurement for it actually. Countersink tapped clearance hole. Maybe there are only 4 holes. Because here's our drawing. Okay. We got information for the top hole, this hole, this hole, this hole. This hole here doesn't have a leader line to it, so I don't have enough information to be able to create it. So, but here it's saying there is a hole. So let's look further into the instructions. It says you're going to create a clearance hole. Okay. Okay, so if you go further down and you get to clearance hole and you open that up, you guys will be probably closer to a 2018 Inventor menu. Alright, you're just going to make it look like this, okay? So for us, we would have that, we would have this selected. It'll load. Or my computer will crash, one of those. Alright, ANSI unified screw threads, hex head bolt, size half, fit normal, termination through all, and a diameter 0.5 through 1, apply. Okay, so there we go, that is our hole. Okay, and that was once again, it's not up here, Okay, you scroll down and then past those, and it's underneath the drop downs under clearance hole. Okay, so that's how we can do that. And then one last thing is, if you didn't realize, I did not extrude this the correct distance. So even if you forget to do something, you can always go back, and you don't have to go all the way back. But if my extrusion is incorrect, I can double click on extrusion here, and I can change that to 1.5. And now that's fixed. Okay, and that did everything. Alright, so I'm going to go and save this, and you should too, once you get to it. Save as, I'll call this, holes. You'll save it to your H drive. And then for number 4, I am not going to do that for you. You should be able to do that on your own. At this point, now that we've covered out how to do a circular pattern. So you will use that circular pattern again to create that. So good luck on that. If you have questions, talk to your classmates, talk to the substitute. Once again, you can email me, but I can't promise I will get back to you. If I am available, I will. But other than that, good luck, and we'll see you in the next video.